we'll have a Kubernetes Day 10 session, right? Kubernetes.
Yeah.
In the last session, we had left at the limit range, right? So in the last session, we discussed about what is resource quota and limit ranges. As we discussed at resource quota, it is applicable on the namespace, right? Basically, if you have many projects in your organization and you want to build that projects everything under your Kubernetes and you are choosing a Kubernetes cluster, right? Then what happened that each and every Kubernetes cluster has some resources, like it might be having some number of GB of hard drive, number of the core processors, right? And number of maybe some 50 GB or 100 GB of RAM, right? So you need to divide the whole resource across all the projects actually. So to control over that resources, right? Whatever the resources we have, right? Kubernetes resources, we have to have a resource quota actually. So once we have a resource quota, you can set up a limit on the resource quota. Like you can set like how many number of pods you have to create, how many number of how many number of memory you have can set, CPU core you can set, persistent volume, what else, and even like services, even like there are many resources, right? So all those you can set to this resource quota, and resource quota, as we said, right, it is only applicable to the namespace. You cannot set a resource quota to the node or to the cluster, correct? Similarly, what happened, right? Now what happened once you have set it, now finally what happened, why we are using a limit range? Limit range because we are using that, we are using, again, what happened within a namespace, you might create many more sub projects, like a developer can create their own projects, right? So even so, if you have a resource quota, I'm just recalling this. So if you're having a resource quota, so this resource quota, what happened, right? With the help of a label, you can actually set it to some node, worker node, right? And within this worker node, like this is worker node 1 is there. Now here what is happening, that again what happened, you might create a number of projects within that namespace. This is a namespace, and with the namespace you have set the quota. So if you have multiple number of teams actually within that same namespace, you can even have a multiple projects like dev project, test projects, or prod projects, right? Again, what happened, right? You need to divide, or you need to have some kind of a limits for the number of pods to be created by that individual team, or the number of CPU usage, or number of the memory usage. For that reason, we have a limit range actually. And limit range, we can set it to limit range. We can set it to pods. We set it to the containers, and we can set to the volumes. This is what we had discussed. And last class, I remember we had seen up to containers, right? Containers. Now what we'll do, we will see with the pods today actually. Okay. And volumes, as I mentioned, right, still now I have not yet covered the persistent storage volume. So I will be taking up this at the later stage actually. Now, okay, that is one thing. So let me do one thing. So I think I have not logged into my machine. Let me log into my machine. So this is my AWS console, and I already have two machines, like master and worker one node. So you can see that there are two machines are which are running. I don't have worker two because I don't need it actually. Okay, so I'll connect to the master. So this is my master node. We need to switch to the root user. And after that, if we execute the command kubectl get nodes, you'll be seeing what all the different nodes are there here, part of a class. So master and worker one, correct? Now, what I told you, right? Like what we have to discuss today is that we need to discuss about the limit range for pods, right? So you can even go to your this one Kubernetes limit range. If you'll get a very good document, you'll get a lot of stuff in the limit range. So here what happened, right? In this section, they have discussed both for the pod as well as for the even as far as for your even what for your container also. Everything is there. You can go through this document actually. Okay, limit range. Okay. Now what is happening is that let me do one thing. I need to have an example actually. If you go through my previous, see here, I have a YAML file actually. So this is for the pod YAML. So let me do one thing. Let me copy this. Let me copy it and then check nothing is there. Let's say wget and okay, I'm just downloading this file actually. We can even do a kubectl. Okay, create a -f and you can specify this complete path. Like that's all. Like this also you can do it. So I'm just downloading this file actually. YAML file. Okay. So once I download it, you could see that I have a file. So let me open this file. Guys, some noise is coming, right?
What sort of noise now, Rajesh?
No. Actually, from my back, the neighbors, they're running some music or something.
No. We are not
You
getting
guys
any.
are not getting ready, yeah,
No.
because it should not disturb the recording.
Yeah, no.
Okay, great. Then it's fine. Okay. So now you could see here that in our this one in this example, right? Now you could see that like we have an API version v1 fine kind. In the last session we have seen that limit range, and we have a metadata, and this is the name. You are only one field you are giving, that is a name, and you are specifying the pod name actually. And here you have a spec. Within a spec actually you have a limit actually. So you have to go through the API reference kit for understanding the limit range. Hmm? There you will get all these things. Here what happened under the spec actually, you have a limits actually. Under the limit, you have a max, something like maximum, how much CPU you want. I want 2 core CPU. Okay. What is the memory you need? 2 GB. So these are max you have set it, sir. You have not set anything your minimum. Here, even you can set as a minimum also, but we are not setting minimum here. Okay, we'll see, we'll check later. If I want to set the minimum also, I can set it out. And the type is pod actually. See, in the last session, you remember, right, when we had created a limit range for the containers, the type here we mentioned as a container, correct? But here this time it is a pod actually. So let me do one thing, let me save this file. And then what I will do, I will just say kubectl apply -f and specify the YAML file. So we applied it, correct? Now what happened that if we execute kubectl get the limit range actually. Limit range. Okay, you could see that there's a limit range that's been set for the pod. The same thing. I'll do one thing. I'll do a describe actually. Kubectl describe and what is called limit range and specify this resource. Now you could see that whatever you have set it here, you could see that the max CPU is a 2 core and the max is memory is 2 GB. The minimum column is what? You don't have anything, okay? Because in your YAML file you have not set it, fine. Now in the default request and the default limiter, default, suppose you don't have a min and max, what is the default? In case of a pod, nothing is there, okay? Now what I will do, I need to have one more YAML file where I need to make use of this CPU and memory, right? For the pod. For that, what I will do, I will see here, I have one more link over here. I'll copy it So what I will do, I'll do again wget specify this file. I mean specify the URL. Yeah. Now it has downloaded it, and if I do an ls, you could see that this is the YAML file. So let me open this YAML file. Okay. Now it's the same thing, more or less, whatever we have seen for YAML file for related to the container, right? In the last session when we executed, right? So here also, what we have that we have an API version. So let me don't think I will just add this -fm. If you don't add also, but fine. But it's always good practice that you should always mention 3 hyphens because it specifies this is the beginning of your YAML file. Okay. Now here what happens? See, because you are want to create a pod now, you are having API version. That's v1. Kind is pod. Metadata. Okay. What is the name you have to give for your pod actually? So the name you have to give as a busy box too. After that, you have a spec actually, and within that you have a containers, and you could see that there you are actually creating n number of containers. Container number 1, busy box container number 1, container number 2, container number 3, and if you come down, the container number 4. Correct? There are 4 containers. Let me do a thing. I don't want to edit it. Let me first take a backup of this file. Limit range and limit range. Yes, I can even do the copy also, but just untick it. So let me open this file. Limit range -pod. So what I will do, I will remove everything, sir. I will remove everything. I just keep only one container. Now, if you see this here, now you know very well that now if you see here, we are actually creating only one container, right? And within the container, because container is an array type, it's an array type. That's what after container, you know that after that you have to put hyphen, space, 2 spaces, and give name, and what is the name of your container which you're creating. This is a name. And after what is the image you want to use, I'm using the busy box, and this is nothing but the command and the argument, whatever the command and the argument which you want to run inside this image, that is what you are mentioning over here actually. After that, you know that there is one more field, the resources actually. This resources will specify that what is the resources where your container has to use it. For example, it uses the resources like memory and CPU. So here what is happening that you have something as a under the resources we have a request, under again you have a limits. So limits means what is the maximum memory and CPU which your container can take while it is running. So 200 MI megabytes is the memory it uses, that is the RAM memory, and the CPU is the 500 milli CPU. Similarly, what is happening is that you have this is the maximum and this is the minimum, sir. Whenever you see request here, you have to understand this is the minimum. Wherever you see limits, actually, this is all under request only, sir. Under the request, under the resources. Under the resources, limits means max, request means minimum. That's what you have to understand. Clear, sir? So now what is happening that here you are mentioning that what is the maximum limits where your pod can take it up while creating it. This is the maximum. And what is the minimum it can have? This is the minimum. So whenever the pod get created, minimum it will get this much. It cannot go less than that. And maximum it can go up to this much. This is what the limit ranges we are giving. So let us save this file. Let us save this file. And I'll do one thing, sir. Let me open one more session actually to make it. I'll open one more, the same master again. Guys, are you getting any sound actually? For me, it is terribly, I'm getting a lot of sound.
For us here, we don't have any sound, sir. We didn't get any.
Yeah. Ultimately, it should not disturb our recording. I mean,
Yeah, recording good only, sir. No issue.
So here I have shifted here. Now what I will do, okay, let it be. Now what I will do, I will go here, and what I will do, I will try to apply it actually. So what I will do, I'll check kubectl apply -f and specify this YAML. Okay. Now if you execute kubectl kubectl get pods. Let me check if it is creating pods or not. See, it has already created a pod. So you could see that actually, because in this YAML file you are mentioning only one container. That's what you are having a desired state as one. What is the actual state? It is one only. It means that you are actually getting one container, because inside that you are having only one, right? And it is in a running. Correct. If you do a kubectl describe pod and specify this pod name, now you could able to see here that it is what it says. That see the CPU, the what is the minimum where your container can take is up to 100 millicore actually, and the memory is 100 megabytes. Similarly, what is the maximum? 500 what? 500 millicore, and 200 is a megabyte maximum it can take it actually. Clear, sir? Now, okay, this is what it is, and this is what the events you could see it actually. Correct. Now you say that actually, okay, Rajesh, when I execute this command, kubectl get limit range. Okay, I need to display the limit range, and I will check kubectl describe limit range and specify this name over here. It shows that actually that you are having a CPU of 2 core and the memory of 2 GB. Correct? 2 GB. Now the same stuff here, like for example, if I open that limiter, here what is happening is that you could see that the pod, the maximum memory you can have is up to 2 GB. Okay, so here it is 2 GB, right? 2 GI. Suppose assume that you, okay, assume that, okay, I will do one thing. I'll try to change this max actually to 2 to 3. Right, max 3 GI, right? And I'll change this file. Before up, so I've deleted it.
I think your screen is stuck, Rajesh.
Now also.
Yeah, now it has just released.
Yeah, sir. This will not show like why it's happening in the Skype itself. Even I have watched many of the previous videos. A lot of stuff is happening actually. We'll sort out this issue. So we'll see. Yeah, now it is deleted. Now you we have seen that actually under the limit range pod, right? We have increased the max limit to 3G. But here the point here is that actually you're having a max 2G itself actually. So now whether it will allow us to run this container or whether it will create a container. Let us see kubectl apply -f. What else? Limit -range. See, it will not allow at all. What it says that the pod is 2 GB, but the limit what you're asking is 3 GI you're asking. So you cannot create it. Right? So this is what you have been checking. Now, so let me do this. Let me pull back to what is the 200 MI. So now that is one thing. Now what is happening that Rajesh, you say that okay, fine. Here what happened that you don't have a minimum. Can I set the minimum again? Yeah, you can set the minimum. VI. You can open the YAML file. Okay. Now here, what is happening is that actually, yeah, minimum CPU argument was 1, and memory what I'll give? There's a 2 GB, yeah? But 1 GB, 1 GB. Okay, sir. So here I've set the minimum CPU core 1, memory as 1 GB, max is 2 GB. Okay, minimum is 1 GB. Fine. Let me save this file. Then I will say kubectl apply. I need to apply right again for this. After do the changes, you have to apply it again. So it is reconfigured again. Now again, if you execute the kubectl describe limit range, now you could see that the minimum has been set now. Clear? Minimum has been set now. Now, if you go to your example of your pod example, limit range pod, right? Now you could see that actually your max you're having is this one, and the minimum has having this one. Do you think that still it will run? Because here what happened, minimum itself is 1 core and minimum CPU core is 1 and minimum memory itself is 1 G. Here you could say minimum itself is 200M, minimum of the CPU itself. So it is lesser than what is been specified over here. So it means that it will not run. So let me check again. I'll apply this. kubectl apply different f limit range port. See, it is forbidden. You cannot do it, right? Correct, sir? Now what I will do, I'll open this limit range, or let me do anything. Let me increase it, sir. Actually, what I will do here, max itself is medium max itself. So I'll do one thing. Let me increase it to 2000 mi. Okay, and max I'll do it to sorry 1200, right? And here what is it happening, that memory minimum of 1 GB, right? So we'll do as a minimum of 1100 just to see if it works or not. With that we are checking it, right? And here CPU core is 1. Okay, let me increase it to 1100. Now I think it has to run. Now it should run. 1000 less than or equal to the CPU limits. Okay, CPU limits, correct. So here what is happening, that you can give here 1 GB only. Yes. Because that is a minimum, and the CPU is 1. I think that will go. Sorry, I think I have to change it over here. I think what I have to do here. So here this is the max limit. So max limit is 1100. Okay, fine. And CPU is 1100. Okay, fine. Minimum, minimum. What is it? Minimum you have to give as a 1 here as a 1 GI. Okay, 1 GI and CPU as 1. Now it should work. Okay, now it works. See, it works. So now you know very well like how I can control the pods, and I mean when it comes to the resources, right? I know very well like how to do the pods. So what I will do one thing, I'll go back here and open that same file. I limit. I don't want to give this minimum. Let me remove this minimum. Okay, save this one. Then again apply it. I'll clear the screen and again I'll apply it, and again I'll do a display. Okay, we got back the same stuff. Now here again, I don't think I'll remove this. Delete -f limit range. So I have removed it actually. I have deleted it. Okay, sir. Now here what is happening, that if you see the complete example here. So let me do one thing. I'll remove this file actually, because already I have a limit range, right? Yeah. So I have this backup file. So let me check backup first. Or else I can even do a wget again for this. But so let me open this file again. So let us see now. This is fine actually. Okay, this is the container, first container. In the second container, see here in the second container, what it says actually, that in the second container you are giving a minimum here, minimum resources, but here you are not giving any max. Correct? Max means this will come, right? Limits means max, right? Here you could see that there is no max, there is only minimum. Fine. Okay. In the third container, like this is our third container. In the third container, you have given a max. Correct? And afterwards, if you come down here, Here in the container, in the last container, you are not giving anything, minimum max. Now, do you think that this will work the whole example? It will fail. I'll tell you before. So I'll save this file and I'll say kubectl apply -f and specify this. Now you could see that max to forbidden, box to forbidden. Where it is forbidden, see, maximum CPU aspect is to, no limit is specified. See, no limit is specified. Where in the second container, not specified in limit at all. Maximum memory used per is 2 GB, no limit is specified. Okay, it means that we have not specified any limit itself for the second part actually. So that it means that what it clearly says is that actually always whenever you are creating a pod actually and you are setting the resource actually for the pod for the pod for the pod or the container, you need to have the maximum limit should be there. If minimum is not there, it will work still, but maximum has to be there. So if you do it, let me remove these lines now, just to showcase you that. To assume that actually you instead of requests actually to have here limits. Okay, limits. Let me see it is aligned or not, because the alignment is very important. Yeah, it is aligned. Okay, and memories. See what you are doing here. You are giving a max of 100 MI and max CPU of 100 M. Means 100 MI 100 megabyte and the CPU is 100 millicore actually. Here what is happening? You are given both the minimum as well as the maximum, but here you are only giving the max. Now let us see if it will work or not. So kubectl apply -f limit range or see it's working. Kubectl get pods. See, now you could see that. See, you are able to run. Now if you do a kubectl describe and specify the pod and give this. See, here what is happening that you can make out guys very clearly. Under the describe, you have a containers. Under the container, you have a busy box contains your own. This is the first container actually. So the first container, you could see that whatever the max you had set to 500 M for the CPU and 200 MI, that has been allocated. And even the requested, that's the minimum it has been set actually. Here what is happening is that we could see that actually the max you have set it as a 100 M for the CPU and the memory also 100 M. Even the minimum also it has took the same value, sir. Because here, if you see it right, there is nothing minimum over set over here. It is not set over here. That's the reason what is happening that whatever the value you have a max, right, the same value it will even take for the minimum also. So this is one of the interview questions. So what is happening that if we say that if in the limit range, if you have not specified what is the minimum, what Kubernetes will provide the minimum value. You have to say whatever the max has been set. Same thing for the minimum also it has been set actually. Like that you have to say. Okay, sir. So this is one of the interview question. Clear, sir? Now if you that's all. Now let me remove it. kubectl delete. I think hope you understood what I'm trying to tell you. Okay. kubectl delete -f limit range right and delete it. So that's all, sir. Now you know now at the end also, I mean in the main original file, right, whatever the limitrange pod.yaml, what are the 4 containers are there, even at the end the last container, that will also not, it will not work out because you don't have set the max limit over there actually. You don't have even set the max, even you have not even set the minimum also. So in that way it will not work actually. You have to specify minimum, you have to specify the max limit actually, right? So if you see here, this is my backup file. So if I open the same file, you know very well that in the last container, see busybox 2, okay, busybox 3 also will run. Why? Because see, it will run because it has a max actually. If you don't have a minimum also, no problem to run. Whereas in the last container, you could see that it doesn't have anything maximum. It will also will fail. This one also will fail. So this is one thing. Now there's one important thing which you have to understand. So what you have to remember, or which you have to make a note of it. Now in the last session, you remember that we created the limit range for the containers. Actually, if I do a wget of this file, I'll do it here, not here. Do a wget of the file. Here I got this file. What is that? CPU limit container. This file. Actually, I open this file. Now you could see that the limits for the container you have set as a max and you have set a minimum. But here you have set the default also. Default minimum, default maximum. This defaults will not be applicable for the pod. It will be only applicable for the container. This is what difference of the limit range between the pod and the container. So I have to say that if any person asks you, sir, what is the difference between the limit range for the container and the pod, you have to say that in a YAML file, or the defaults max and the minimum default is not applicable to the pod. It is only applicable to the container. Correct, sir? To prove it, actually, you can even copy this. What is it? Copy this, and then open this file, open this limit, open mem CPU pod.yaml, right? So this is the file. Suppose assume that I set it here, actually, like this. Okay, I think I have to align it. No problem. So what I will do, I will check cat of limit. Open this file, okay, and open this file. So what I will do, CPU memory, and default request, default request. Means if this is the default, this is the minimum actually. Then minimum it will be something like for the CPU, what is the value? Something like 800 MB, and the max minimum for the memory will be something like again 700. 700 here. Now what I said, like for the pod, default and the default will not be applicable. Let's see. So I'll save this file. I'll execute the command kubectl apply -f and then say limit range, not the limit range, limit mem CPU for the pod. See what it says, forbidden, may not be specified and type is pod. See, forbidden, default, and the default request is forbidden. You cannot apply the default value. See, this default values, default is not applicable for the pods. So as a default request, there's a minimum and the max will be applicable for the container. Is it clear, sir? Guys, is it clear for you?
Yes, sir.
So default is not applicable for the pod. It is only applicable for the container. That's what you have to keep in your mind. Okay. So that's what, guys. This is what I want to tell you about the limits. Okay. So we have completed the limit range. Okay. Now what we come is we will try to understand about the replication actually. Okay. Replication, or we can call it as a controllers. Pod controllers. Now, what is it actually? What is a pod controller? See, suppose for example, okay, so let me remove everything. security kubectl delete delete f and specify the pod.yaml. Okay, I deleted it. Just check if kubectl get pods. Just I'm trying to check. So nothing is there. Okay, get limit ranges. Just I'm just verifying if anything is there or not. Okay, nothing is there. Fine. So nothing is there. Everything is clear now. Okay. Now, what is a replication or what is a controller? See, suppose for example, suppose I'll create one container. Sorry, I'll create one pod actually. So kubectl run web hyphen server hyphen image is equal to engine. We know very well this, right? We will keep running. So what it will do, it will create a container. It will create a pod. So you could see that a pod with the name web hyphen server has been running. It's created and is up and running. Suppose tomorrow what happened, right? If there is some issue with this running pod, or there a pod has been crashed actually. So whether the Kubernetes system is going to recreate this pod again? No, it will not create it. Because why it will not create it? Because there is no control on top of this running pod actually. If there has been any control, then it would have got created, right? Suppose for example, if I do a watch kubectl get pod. Suppose I'm watching it. So I could see that container is up and running. Sorry, the pod is up and running. Now if I come over here and if I execute kubectl delete and specify the pod name web hyphen server, see the pod is getting deleted. See, it is getting get deleted. Now do you think that the pod is getting recreating it again? No, right? It's not getting recreated again because there is no control over that. So what is happening is that actually you need to have some kind of a controller to which actually, even though a pod is running and if the pod accidentally it will get deleted, or if it get terminated, or if the pod get some issue because of which the pod goes down, or if it is not responsive, then the controller will take care of recreating the pod again. Okay. It is same thing like a like autoscaler in AWS. In AWS, we have something as autoscaler. So what is autoscaler means? Basically, suppose if I create a VM machine in AWS, and if there is some issue with this VM, if there is some problem with the VM, now what is happening there, or if this VM machine came down actually, if this VM machine will came down actually, do you think that the AWS is going to recreate the VM again, a new VM for you? No, right? It will not create it automatically. Then what we will do that you will set up an autoscaler for that VM, for that machine. So what happened that this autoscaler will be keep monitoring this machine which is running. As soon as this machine comes down because they based on some issue, this autoscaler is going to recreate the VM again. So we have a facility in AWS cloud, which is not called autoscaler. Similarly, we have something in your Kubernetes which we call it as a replication. So we have a replication, or in our terms, we can say it as a pod controllers. Okay. So replication or pod. So to be very specific, we say the replication types. Okay. So what is the topic means? We have to start with the discussion about Kubernetes replication types, or we can call it as a Kubernetes in our terms, Kubernetes pod controller types. Okay, sir. So this is what the topic of today. So we'll be discussing about the replications. So basically, the Kubernetes, it provides three types of replications. It provides three types of replication. What are those replications? So the replications are replication controllers, controller, and what else? You have something was a replica set, That's it. And one more is nothing but your deployments. Okay, sir. So these are the three types of replication, sir. We have a replication controller, we have a replication type, and we have a deployments. So same thing. Suppose like you create a pod actually by running a command, kubectl, same thing, kubectl, run web server hyphen image.next. And if you have set any one of these controllers on top of that running container, so this controller will take care of recreating the same pod, even if the pod will get terminated, or even if there is a if any problem happens, if there is some issue had happened where the pod has gone down, these controllers will take care of recreating the same pod again. So you need not to worry it actually. Okay. Now we need to understand that what is this three different controllers or replica controllers are there. What is the difference? We have to understand it, and when we will be using it actually. All those things we have to understand now. Okay, so let's understand through the diagrammatical format, sir, how it works actually. Suppose, for example, I have a pod, sir. Assume that I have a pod. I have a pod actually. Like I have a something like pod one. I have a pod which is running. Suppose assume that I have set a suppose I have a pod and I have set a replication control on top of that pod actually. So this is nothing but your replication controller. So now what will happen that, okay, what this will happen that if there is a replication control you have set on top of this pod, so what is happening is that this pod will be under the control of that replication controller. It will be under the control of the replication controller. So if this pod goes down due to some reason, this replication controller can recreate one more same pod will try to recreate it. Okay. Now the thing comes that here we are talking about only one pod. Like, can we create a number, or can it monitor a number of pods? Yes, it can monitor, sir. It can even monitor a number. I don't want to create a replica controller only to monitor only one pod, right? I mean, why I have to monitor only one pod? I need to monitor more than a lot of pods I want to monitor. So like that, what happened that you will create n number of pods actually, right? You have a n number of pods. Okay. Pod 2, pod 3, pod 4, right? So what is happening that all these pods will be monitored by the same replication controller. Now, how the replication controller will know that I need to only monitor these 4 pods only? Suppose assume that there are 100 pods running in your machine and you have set the replication controller. How the replication controller will know that it has to monitor these 4 only? Because the replication works with the help of a labels actually. If there is a specific label is set for this pod, you can monitor only those pods which is having that specific label. Like what happened, right? We say something like we have something like a selectors we say actually. Okay, selectors. Okay, what is it? We'll get to later on. Suppose if this selector is having a name something like team is equal to Dave. Okay. So the selectors and what the labels are. So if these pods, right, what are the pods we have, right? If this pods having the label something like team is equal to Dave, okay, even this pod also has the same label, sir. Team is equal to Dave. This pod number 3 also has the same label. Team is equal to Dave. And also even the 4th pod also will have the same label. Team is equal to Dave. So whichever pods which is having this label team is equal to Dave, no sir, then all these pods will come under the control of that replication controller. Then when any one of the pod will get deleted, what this replication control will do, that replication control will recreate the same pod again. Suppose replication control says that okay, I have to always monitor the 4 pods. Means my desired state is always 4. It means that it says no, I want to always have the 4 pods always up and running, right? So these 4 pods will be monitored by the replication control. How it monitors? Based on the label, because all these 4 pods are having a label, something like team is equal to day, or team is equal to day, or team is equal to something. So all these 4 pods will be under the control. If any one of the pod will get deleted, or it knows that oh, I have a desired status of 4 actually, but right now 3 are running. Oh, let me recreate it. It means that it understands that one pod has gone down. Let me recreate it. That's how the replication controller works. Any doubts, sir, till here? Till here, if you have any doubts.
No, Rajesh.
Clear?
Clear, Rajesh.
Okay, one shot clear, huh? Okay, great. Yeah. So now what is happening is that this has a controller all the pod. Fine. Now it's okay. Okay. Now what is happening is that actually, so because that you have given the name label as a Davis or thing, that's what it is. Suppose you say that Rajesh, if there is one more pod, is there some other pod is there? Some other pod is there, the pod number 5, and that is having a label as team is equal to prod, actually something. Now do you say that Rajesh, whether this pod will be monitored or this will be controlled by this replica controller? No, because here the label is different. So it means that replication controller can only monitor only one label at a time. It cannot monitor the multiple label. So what is it? Replication controller can only monitor or can only control or monitor, whatever you can say, but can only control the pods. No, can only monitor, right? Monitor only one label as the selector. It cannot monitor multiple labels. So that is the drawback actually. So if in an interview they ask what is the drawbacks, you have to say that a drawback is that it cannot support multiple labels actually. It means that it can only we have to say that it only monitors the equality set of pod. You have to say that it only monitors the set based, not set based, equality based is that only one label it can monitor. Simple. Okay. So this is one thing. Okay, that's a drawback actually. So in case of a replication controller. Yes, sir. That is one drawback. Now you say that okay, Rajesh, fine, these pods are running now. Now suppose some person outside the internet, he want to access this pod actually. So then what is happening that on the top of this replication control, you need to create a service actually. You need to create a service. Okay, you need to create a service. And you know, like we have discussed from long time, we have different types of services, right? We have a services like Stripe, node port, as well as a load balancer. So I'll be using something like a load balancer. We will be having a separate topic on services later. Okay. So right now, just try to understand that on top of this replication control, we have some kind of a services actually, and the type we can maintain either you can have a load balancer or either you can have a node port. But most preferably people are choosing the load balancer itself. Now, what is happening that if you are having if this is a net, and if suppose some person is actually sitting here in a system, and is a person who's sitting in system, and if he want to access, or if you want to communicate, or if you want to access the application which is running in the pod, he'll try to connect to the net actually from the over the net. He'll try to hit to the service load balancer, and this service load balancer is integrated or it is bonded with the replication controller. From here, the traffic flows to the pod actually. Like this, it happens. So this is the scenario it happens actually. Okay. Now what is happening is that here what happened, right? The drawback of your replication controller that actually it can only monitor only one set of label. It cannot monitor one set of label. So that is a drawback. So that drawback, what they have did, right? They have overcome in the replica set type actually. Now what replica set type says actually, that replica set says that actually now suppose you are having, if you're having a replica set actually as a type, okay, if you're having a replica set actually, what replica set type says that actually I can monitor selectors or the labels which the type is team is equal to Dave. Also I can monitor all the pods which is having the label. Even I can even monitor team pod. So now what is happening? The same thing. If you are having a pod over here, suppose I'm having some 4 pods here. I'm having 4 pods, and here this pod is having a label team is equal to Dave, and the second pod is having the label team is equal to Dave, and the third pod is having a label team is equal to prod, and the fourth pod is having the name team is equal to prod. Then you're having a different set of labels over here, right? So the replica center, now what is happening, that the replica set, it can control even the all the pods, even if it is having a different label. This is what one difference between the replica controller and the replica set. You have to say replica set is just one enhancement here, that instead of just monitoring only one label, it can even monitor the multiple labels. That is a one small difference, you have to say. Okay, the difference between replica set and replica controller. So same thing again, that here also in the replica set, if anyone want to access this monitor over the internet, what is happening, that he need to have a service actually. You need to have a service like this, right? And the service can be of any type. It can be a node code or it can be load balancer. Right? And now what is happening, that so there's an internet here, right? Now what happened, whenever you want to access this any of the pod, it will try to connect to the net. From there he'll try to hit to the service, and from the service he'll try to send the traffic to the replica set. Replica set knows like where I have to distribute the traffic. So this is how it works actually. We also will have it. Here. Okay. Now the question comes actually, okay, fine. We have the replication controller, we have a replica set. And the difference of this replica set is that replication controller will support for only one label, okay, or it can only support like one selector. Whereas in the replica set, it can support the multiple labels or multiple selectors. Here it supports the set-based selector. That's what it says. That replica set. Here it supports the equality-based selector. Whereas in the replica set, you have to say that replica set, it monitors or it supports or it monitors the set-based selectors. It means that basically more than one. Suppose you say that, Rajesh, I want to monitor Dave as well as a prod, but I don't want to monitor something like that, something was a test actually. Even that condition also you can add actually. In the replica set, you have said, I have to monitor Dave, I have to monitor the prod. Suppose that there are some more pods are there where the label is tester, team is equal to tester. I don't want to monitor those things. That also you can add a condition over here. So that is the beauty of replica set actually, that you can have even the the conditional way where you want to monitor certain labels with having that pod, and many other which you don't want to monitor. Like that also you can mention it actually. So if you see the practical, when we are doing the practical, you will appreciate more in that during that time. Okay. Now that is one thing. Second, what is happening? That what is the difference? Second difference. First difference that here it is only one label, and here it can have a multiple label. Correct. Second is that actually when you want to do a rolling upgrade, assume that actually what is the meaning of rolling upgrade means. Suppose for example, here this pod one is having some application which is running. Assume that some application. I'm just taking, suppose if you're having the Nginx which is having a version 1.7.1. Okay, so this is the application which is running in each and every pod. Okay, now you say that Rajesh, there's one more new version has come. Okay, which is nothing but Nginx 1.9.1. Now you say that Rajesh, I want to upgrade the pod, the application which is running in the pod from Nginx from 1.7.1 to 1.9.1. So this replication controller will support for the updates, rolling updates. So what have we say that replication controller will support for rolling updates. Rolling update of what? Rolling updates of your container or the application with the rolling update of the applications which are running inside the pod. Whereas a replica set will not support any rolling updates of the application running inside the pod. These are the two differences you have to tell. If somebody asks you, if the interviewer in the interview, if they ask you, you have to say what's the difference between replication controller and replica set. So replication controller can only support one type of label, that is only one selector it can support. You cannot have a different labels with the having a different labels. It cannot be supported by the replication controller. To overcome that, actually we have a replica set. In the replica set, you can have a multiple selectors. You can have something like team is equal to dev and team is equal to prod. All those pods which are having these two labels can be monitored by your replica set. That is the difference actually. That is one difference. Second difference is that replication controller will support for your rolling update, whereas a replica set will not support for your rolling update. Clear, sir?
So then, Rajesh, one quick question. So in this case, if we need to actually version upgrade an application using replica set, if it doesn't support rolling update, then what is the other option can we choose, or will it support?
That's what comes. That is what this disadvantage it has been there. It has been covered in the deployment.
Okay. Yeah.
But deployment is a third part. Now what we say that we have seen that disadvantage, you cannot do a rolling upgrade in replica set. To overcome that, actually we are having a third type which is not the deployment that supports
right.
that supports the rolling upgrade also.
True,
right? So now what is happening that now what they did, right? Same thing, whatever the replica set is there, sir, in deployment, same replica set also here also in deployment, same thing it is used, sir. Same replica.
Rajesh, is any limit has been there for replica set, like labels? How many labels we are going to configure for replica set?
That's so it depends upon node, no, sir. So this is running. This is per node, sir, and per node is having 110 pods, right?
Yeah.
That's what limit we saw, right? So you can have 110 pods labels you can monitor by the single replica set. If you want to have more pods, actually, then you have to increase your pod values. That again we have seen in the last class, right? So limit ranges. Yeah.
Got it.
So here what is happening that here in the case of deployments, you are having the same replica set, same thing. There's no difference. Same whatever we have, same thing here. But here on top of this deployment replica set, we are having something known as a deployment. We have a service known as a deployments. And again, what is the same thing here? We are having a pod over here, which suppose I'm having some multiple pods, like 4 pods. Pod 1, pod 2, pod 3. Pod 3, sorry, I think pod 3. And here it is having some label. So team is equal to, what is it? Team is equal to Dave. Team is having team is equal to Dave. Same thing. Team is equal to Dave. And here this is team is equal to prod, correct? Team is equal to prod. And team is equal to prod. It is written, huh? It's not written. Team equals prod. So now that is whatever the disadvantage you are seeing in case of replication set, it has been overcome into the deployments actually, right? So the same replica set is over here and which can monitor the different labels here with the different parts. But on top of this replication set, you have one more service which we call the deployment actually. So with the help of the deployment, it supports the different labeling, different selector, as well as it supports even the rolling update also. So that's all. Again, the same stuff here on top of the deployment, you need to have a service over here, service over here, service over here, and that service is of a type load balancer. As I said, in the upcoming classes, we will be discussing about services, about different types of services like cluster IP, load balancer, as well as a node port, right? Those things we will see later, actually. Okay, and here we have a net, and if this customer you want to hit, so he'll come through the net. From here he goes and sorry, he will hit to this service load balancer. From here the control goes to the deployment. From the deployment again the control goes to the, I mean, it has been binded to the replica set, and from the replica set the traffic flows over here. This is how the flow goes actually. Okay, network. I mean, when you're accessing over the network, this is how the flow goes actually. Now here what is happening, right? Now we understood very well that we are having a three different replication or the pod controller types we have, right? One we have a replication controller, other is a replication, and other is a deployment actually. And the deployment, it supports both, right? It supports the multi also, and it even supports the rolling overhead. So in that case, you might ask, right, in the industry, whenever we are want to have a replication controller or the pod controller, does all the people always use the deployment? Yes, that's how it is. Now people are stopped using the replica set or the replication control because we are getting all those features here in the deployment only, right? Then why you have to implement these things? So now most of the time, like people, well, not most, every time people are using deployment itself as a replication control type. They're not using replica set or replica. Okay. Now, just for a theoretical discussion, what we're doing, they might ask in intro, they might ask, okay, what is the difference between your deployment and the replication control? So, what is the question they ask? What is the difference between replication controller? See why I'm typing, because some people ask me like to type all the interview questions. What is the difference between the replication controller and deployment? Or what happened, right? Sometime what happened, right? The interviewer might confuse you. You'll say that, okay, Rajesh, okay, I say that I don't want to have a multiple labels, man. I don't want to have multiple sets. I want only one label. Means all my pods having the same label, and it supports a rolling upgrade also. So is it fine that I'm using only replica controller? I don't want to get into the deployment at all. Because here what happened, right? I don't know. Here the only one difference that actually in the deployment is that actually that you say that actually you are having a multiple selectors. Even here it is supporting because you are having a pod with a multiple different labels, right? We are having a Dave, and here you have pod. But in some scenario, assume that I don't want to do that. I want to have only one selector that I. It means that all my pods are having the same label. Okay, fine. And also because replication control supports a rolling update also, is it not feasible to use always replication controller? Why you have to switch to the deployment? So that might be asked by the interviewer. So did you understand that question? Did you understand what I'm trying to tell? So the intro might confuse you like this. Correct? First,
Yes.
first of all, did you understood the question or not? That's what I want to know.
Yes, understand.
What about others? If you're not understood, ask me again, I'll repeat it. But don't go without understanding.
Yeah, Rajesh, understood.
So what he said that you are giving condition that I don't want to have multiple labels, only one label, and because replication control also supports for the rolling upgrade. So now what is happening that what is a disadvantage here? Yes, we will still we should not use replication control. Why? The answer for this is that suppose you are doing if you're doing a rolling update from your, suppose your pod is having an application Nginx 1.7.1, you are doing a rolling upgrade. Actually, what rolling upgrade in the background will happen, right? See, I mean, right now it is deprecated. I mean, this feature is not there, but I'm just saying, you are seeing come from the kubectl, you are having some option like this actually. Rolling upgrade and specify the replication name like that. There is some command line. If you give like that, what inside the background happen, right? What it will do, means one more replication control will get created, sir, like this, with some new name. One more replication control, something like replication controller new something. A new replication control will get created. Now, what this new will do that it will try to create because we are considered only four pods, right? So let me remove this fifth pod. Actually. This is just for understanding purpose at that time I told you. But these are the only four pods, right? Four pods. So what it will do when you're doing a rolling upgrade, in turn what happened, right? A new replication control will get created, sir. And then what it will do, no? It will try to create one pod here like this. It'll try to create one pod, and this pod will have an Nginx of 1.9.1. Okay, and then this endpoint will be added to this replication controller. Okay, so once it creates one pod with the 1.9.1, what it will do right here, what it will do, whatever this pod is running right with this one pod, right, that will get terminated. Okay, fine. Again, what happened here? What happened, right? One more pod will get created. One more pod will get created, and which have an update of which will having a 1.9.1. Okay, this will get the endpoint will get updated to this replication controller new one, and after this it creates it here in this replication controller, the second pod will get deleted. Similarly, same thing like that. One more pod will get created. This will have 1.9.1. 9.1, and again the endpoint will get added to your new replication controller. Once it is completed, then the third pod will get deleted. Similarly, one more pod will get created. I will draw it here. Okay, it will have a version of Nginx 1.9.1 because that is what you want, right? And this endpoint will get added to your replication controller. Once this happens, right, the final pod will also get deleted. Once this get deleted, it means that in this replication control, all the pods are getting deleted. Correct? No? Now assume that if all these pods are getting deleted, at the same instance, if the customer or if any client want to access this application, what will happen? He will send a request. The request will come to the service load balancer, and that will come to the controller. But within the controller, there are no pods because you have kept for the rolling upgrade. It means what happened, right? The service is down for some time. Now, what will happen? Internal replication control will do, right? Once it is done, what it will do, right? It will delete this replication controller. Once this completed, it will delete the replication controller. After this getting deleted replication controller, whatever the new replication control is there, right? Even that will also get deleted for some time. It means that right now there are no replication controller at all now. Now the service load balancer was pointed to some replication controller. Now that itself also got deleted. Even the new replication also got deleted. Okay. Now what is happening is that actually now again what happened that one more replication control will get created and it will be having the name of whatever the previous it had. Now what happened, right? Now this service load this load balancer, right? Now this will point to your newly created replication controller. And now this replication controller will have all these updated pods which is having 1.9.1. So here in this replication control scenario, you could see that you will have some downtime of your application, because like the replication control itself is getting upgraded one pod at a time. Once it is getting upgraded, when all these pods under this application control getting deleted, what happens? Your whole application is down now for a few seconds or for 1 or 2 seconds. So during that time, what happened, right? This new replication controller will get renamed to the older one, and because that the service load balancer, right? It has to point to the replication control, right? Then only the traffic comes, right? So that's what happened during that processing time. There will be a downtime of this application. Assume that the same time, if the customer is doing some transaction, if he's doing some kind of a huge billing transaction, then what is happening that what will happen that you will see the customer will face a downtime. So this disadvantages, what is happening that this is the one of the disadvantage in case of replication. Whereas when it comes to the deployment, this is not there. There is no downtime of the application. So I have to say that in replication controller, there is a downtime of the application. That's in deployment, there is no downtime. Okay. Now coming back to here, one more I will tell you, one more thing. Now what will happen that assume that assume that you said, Rajesh, okay, fine, now 1.9.1 is working fine. Now you say that, Rajesh, I want to roll back again back to 1.7. Is it rollback is possible in case of replication control? No, I mean by default it is not possible. There is nothing like an undo option where you have to go from 1.9 to 1.7. That is not possible in case of a replication controller. So you say that no, still I want to get back, means you have to do the same thing again. You have to create one more replication controller, and again what happened that replication controller should have 1.9.71 pod. The same process whatever you do for the undo or for even reversing also you have to do.
Your video is stuck, Rajesh.
No? Are you able to see them?
Yeah.
So what I was trying to tell here, I'll repeat it again. I will say what I was trying to tell that actually, suppose you are having a replication controller, which is now having the latest Nginx 1.9.1 after the rolling upgrade. Suppose you say that I want to roll back actually, in case of a replication controller, there is no rollback. In case of replication controller, there is no rollback. This disadvantages like downtime, rollback, this is being taken care in the deployment. Actually, that's what people prefer to use a deployment. Actually. So in the deployment, what happens in the deployment? Suppose they are saying that, Rajesh, here also in the deployment, you are having pods which is having a same, what is it? Same Nginx 1.7.1 itself or anything, any application. It's not only with Nginx, sir. It can you might be having your own application, right? My application, which is having a version 1.0 in all these pods actually. Now you say that, Rajesh, I want to upgrade my application, my app of 2.0 actually. So you want to do an upgrade, right, from 1.2 to 2.0, which is running in your pod. Now, when it comes to the deployment, what deployment will do, right? Deployment will create one more replica set actually. Create one more replica set like this. So this in the background happens whenever doing a rolling update, right? In the background, what it will do, right? It will create one more replica set, one more new replica set. Now, what will happen that it will try to create a pod here. One pod, it will try to create a pod. That pod, it will having a version of my app as 2.0. Okay, and the endpoint will get added to this particular replica set. So once this is done, what it will do, right? It will remove this pod one. So once it is done, what it will do? It will create one more pod, the same thing. It will create one more pod here like this, and here it will have a image of 2.0 app you have, and the endpoint of this pod will be added to this replica set. Okay. Similarly, like that, once it is done, this pod will get deleted. But here, what happened, right? This pod is getting deleted. Now assume that if the customer is hitting this application, what will happen that it will come to this service load balancer. From here, it will come to the deployment. From the deployment, because since what is happening over here, right? See, what is happening over here is that actually when the replica set is getting created, what it will do that this deployment will add endpoint of the replica set under it also, the newly created deployment, right? Because what happened that here the two pods are getting deleted because the two pods are getting created in a new replica set. Now what happened? The customer, if he want to access to the application, what happened? The control will go to the load balancer. From there, it will go to the deployment. From the deployment, the traffic it can either go to this replica set. Sorry, it can go to this replica set under to this pod, or else the control can go to even to this replica set under this application. So it means that the traffic might go anywhere, either in this replica set or in this replica set. In that case, what happened, right? You are not seeing any downtime at all even during upgrade also. But here, what is happening is that this newly created replica set, it has not been added under the service load balance under the service. Okay, so that it doesn't get added because that it has to create all these 4 pods completely. And then the replica controller, the old one has to get deleted. The new one has to get pointed by it has to get added by your service load balancer as an endpoint. So till that time, till the switch from here to here, right, there will be some downtime because literally the application will not be accessible during that time. Maybe it's like 1 or 2 seconds or 3 seconds, maybe like that actually. Max to max some 2 or 3 seconds, there will be some downtime, right? So whereas here what happened, right, it will create an endpoint during the initial state itself when a new replica set is getting created. Now coming again one more will get created, pod will get created. It will have the same version as 2.0, and this will also get added to your replica set and newly created replica set. One more pod will get, and here this will be removed from here. And one more, what is happening is that actually one more pod will get created that will have the version 2.0, and this endpoint will get added to this replication set, right? And after that, finally, this will get deleted. Now, sir, now what is happening is that now all the pods which are having the 1.0 version are got deleted, and in the other new replication set, the new version of the application 2.0 is up and down. Okay. Now what it will do, right? It will make sure that this replica set, the deployment, what will do now, it will make sure that this replica set should not be deleted. Whereas here in the replication controller, once the new replication getting created, the older replication control will get deleted. Whereas here it will not get deleted. What it will do, it will unset it to 0. It will unset the value to 0. It will unset the value to 0 so that the deployment should not use this replica set. Whereas here it will set the replica set to 1. So that it understands, okay, whenever the traffic comes, I have to send to here, not to here, because here you reset the value to 0 and here you have set the value to 1 actually. Earlier, before the rolling upgrade, the replica set, the value was having 1 itself, so that the deployment know that, oh, I want to send traffic to this replica set. Now, because you have started doing the rolling update, a new replica set got created, and then what happened once all this migration happens, right, from the application from 1.0 to 2.0, then it will. So why it is doing that? Tomorrow, if you want to do undo, you say that no, I don't want to have a 2.0. I want to go back to my old original application. You can reset back to this to 1, so that the deployment now it can start sending the traffic to the replica set to this, so that you will be able to get the pods which is having the 1.1, 1.0 as an application which is running under pod. So here, what is happening? That the rolling back is possible actually. So in case of a replication control, there is no rollback, whereas in the deployment we have a undo, or we call it as a rollback. Rollback facility. So these are the major differences to understand. Okay, sir. So these are the major difference. So now you understood, right? What is the replication controller? What is replica set, and what is the deployment? These are the three major replication, replication types or replication, pod controllers are available. Clear, sir?
Okay, Rajesh.
Yes, Rajesh.
Okay, sir. So I think if I start doing the lab, it will take time actually. So I think we'll stop the session today. So what we will do, we will try to do all our practical labs tomorrow actually. Clear, sir? Tomorrow we will see that actually how we can actually, write a YAML for your replica controller, replication controller, replica set and deployment. So tomorrow's session will be very good because we are doing completely practical. Clear, sir?
Sure, Rajesh.
Sure. Okay, sir. So then we will stop it today because I don't want to really drag. Because if I start taking, I can take another half an hour. If I take it, actually, it will take more time for me. So more than half an hour, it will go beyond. So that's the reason today I'm just stopping very early. Okay.
Okay.
Okay. Chalo then. If you have any doubts, you can ask, or else we can just wind up the session. So you understood the whole background, right? I'm just I have in the top and just in a high level I have explained you. Okay. So what you can do here that actually I'll do one thing. I will give some of the links I will give you. So this is, see, if you want to go, you can even go to the Google and you can just say Kubernetes replication controller. You will get plenty of articles there actually. Here even in our Kubernetes itself, they provide a lot of good articles, good explanation about the replication controller. So, but what is happening is that if you want to have a much more better explanation, then what you can do that here I have some links actually. I'll give these links actually to you guys. I think I already have given you guys these links, so you can actually go through these links. And I feel like one of the link is very good. This first link, right? This is very good, sir. They explained very briefly about all this types. So most of the things which I understood is through this link only. So this has everything, sir. Replication controller and deployment, replica set and deployment. See, nicely they have explained. So with the video they have explained it. See, load balancing, scaling, reliability. If you come here, they have given example also. You can just copy paste and execute the program. It will work actually. See? So I would recommend you to go through this link. So
Sure.
there are many other links are there. You can go through it later whenever you want. And this is the rolling update for the Kubernetes, right? You can go through this link. Okay, guys. So that's all for the today. What we will do tomorrow, we will join at we'll join at 4 o'clock, sir.
Okay, Rajesh.
Okay, sure, sir. Thank you. So I think we can stop the session.
Thanks.
Sure.
Rajesh.
Stop the session.